Okay, we're now recording. So hello everybody again, and welcome to the second session of the Nordic-RSE seminar series. You can find in the chat the link to the HackMD for this session. And in case this is the first time you're here, just a quick background. So Nordic-RSE is this association to bring together researchers, software engineers, or people interested in such in the Nordics. And we organize several interesting and nice events. One of them is this seminar series, which we aim at having every 2-3 weeks. And we have invited speakers, which talk to us about very interesting things. If you want to participate, we would be very happy to have you as a speaker. So you can volunteer as a speaker or suggest a speaker. The best way to do it would be, for example, in the Zulip chat in the Nordic-RSE stream. And if you want to join the organization, that's even greater. And there's the join us form in the website, which you can fill. That being said, the speaker today is Radovan Basta. He's a computational chemist who turned the research software engineer, and he's currently working at the University of Tromsø in Norway. He has been developing several libraries for computational chemistry, text analysis, computational geometry, and moreover, being involved as a fundamental person in Nordic-RSE activities in the Nordic-RSE Association and Code Refinery project. And today he will talk to us about how to interface Python and Rust together. So Radovan, the floor is yours.
Yeah, thanks so much, Luca, for the kind introduction. Hi, everybody. So nice to see you. I will, before I switch to the slides, I will switch one more time to the collaborative document so that you know where to find it. And it's this one here. And here you can add, we can share notes. And here you also find link to the slides. I will go through two examples. So you find the links to the examples and some more blogs and articles and books which I find useful. You can ask questions here, and Luca will help me raising these questions because I might not be able, I have only one screen, so I might not be able to see it if I'm also sharing slides at the same moment. But I think the more questions and the more interruption, the better. So don't wait for the questions until the end. There are no stupid questions. Some questions I will not be able to answer, but it's also okay. And I asked this poll here on top. So how many of us use Python and Rust? And not many people use Rust, but it's okay. I will try to make this interesting also if this is the first time that you see Rust in action. And also thanks for answering these questions, what you like about Python and what you like about Rust. And I will tell you what I like about them. And I need to know, I will stop this share and reopen a different share. And now switch to the slides. I will show a couple of slides, but then I will also show things in a terminal. So I will try to demonstrate these things hands-on. And the plan is to finish the whole thing, depending on how much we discuss, 40 minutes, 45 minutes, no longer than 1 hour. I have 20 slides here. I will not talk about the oxidized metal and the animal here, but it will be about the languages, Rust and Python. And I will discuss why I like to combine these two languages together and how I interface them. And the title is not how to interface them but how I interface them. It may not be the best way. So if somebody knows better, I'm really looking forward to learn. But I will show you what really works well for me and really improve my life quality. Yeah, this was already, Luca already introduced me, so I can skip this slide. Maybe I will have time at the end to show you actually the projects where I use this, Python and Rust. And this is mostly in some computational geometry projects for oceanography. So what we do is we create computational grids on which simulations are run. And we need these grids. These are huge grids, and we need that really fast. And there I work a lot with Python and Rust. And again, please interrupt me at any moment, and let's discuss, and please ask me at any moment. I will try to have an eye on the HackMD, but screen space is limited here. So my plan for today, I will tell you just a very little bit about the history of the language. Where does it come from? Why was it invented? Why are people using Rust? Why do I like Rust? And when can it be a good motivation to combine the two? Why Rust and Python? Then I will show you two tools which I use a lot in this context. One is PyO3, I think Pythonium oxide, so oxidized Python, or well, rusted Python. And the other one is Maturin. So I will demonstrate these tools. And if we have time, the two examples that I will show. But if I run short on time, you can also find the GitHub repository. So in one we will compute distances for a set of points, and there we will be focused on, we want to look at sending simple data structures between Python and Rust, and we will talk about parallelization. And in the second example, we will build a very simple bank account code, and there I want to show how to send my own user-defined object across the language. And then at the end, I will also hopefully have time to show you how I like to distribute this Rust Python mix on PyPI so that you can pip install it. And we will then try to pip install this example, and it will look like any other Python code. So you will not need to know that this is Rust. You will not need to install anything. And this is something that I really like to use so that I can distribute this code also to those who are really familiar in the Python universe, but not in the Rust tooling. So here's a slide about the history of Rust. Where does it come from? It's a relatively new language. The language has started really a little bit over 10 years ago. And it started at Mozilla Research. So Graydon Hoare and collaborators. This started as a personal project, as a small project. It has been announced 2010. And this is really a fun talk to look at. I just want to open this link because it's, maybe just look at one slide of this. It's really fun. So this was Graydon demonstrating this project to, I guess, Mozilla colleagues. And it was a spare time project, small group of people. There was no master plan. Don't worry, we are not going to rewrite the browser. Actually, this is, of course, later they did start rewriting the browser, but it's really fun to browse this history of it. So it started as a small thing. The first stable release, 2015. Then also, this is a fun talk to watch by Steve Klabnik, The History of Rust. Since this year, if I count it right, there is a Rust Foundation. So it's an independent nonprofit that deals with governance of the project. And even if you don't want to use Rust, there are a couple of everyday tools that I really, really want to recommend. So exa, ripgrep, but, and fd. And these are Rust reimplementations of ls, grep, cut, and find. And you really want these tools, I think. So what I do on my computer is I alias ls to exa and grep to ripgrep and cut to but. And this is a very nice summary of 100 Rust binaries that are really nice tools. So check them out. Okay, why do people like Rust? Why do I like Rust? And I like to show this quote by Bjarne Stroustrup, the C++ creator. There are only two kinds of languages, the ones people complain about and the ones nobody uses. So about any useful language, we can find things to complain about. And this will not be a talk about why Rust is better than language X. It's really to crystallize out the positive things about all the languages that we use. And I want to also reconnect to the nice seminar we had last time here at Nordic-RSE, where Luca talked about Julia as a solution to the two-language problem. So why Rust in 2 slides? So people seem to like it. It's on Stack Overflow annual surveys, the most loved programming language for the last couple of years. It is fast, but it is also safe. So it is as fast as Fortran or C or C++, but it is also, you can write safe code. And what is here meant by safe? It's memory safety and thread safety and type safety. And to explain what I mean, so memory safety means that with Rust, I cannot really create a memory leak. I cannot have a dangling pointer pointing to corrupt memory. It will prevent me from doing that. I cannot write code. It will prevent me from writing a code which has race conditions. Of course, unless I insist. So I mean, the main language also has mechanisms to really bypass the safety mechanisms, but these are things that are really nice to have also in research code, because nobody likes to debug race conditions or memory corruptions. And type safety means that I cannot, if a function expects apples, I cannot send oranges to the function. The types, it's a strongly typed language, statically typed, and many people like that fact, and I like that too. It helps me writing robust, correct code. So I don't need to check inside the function whether the thing that I got is really an integer, because the code will not even compile if I send the wrong thing in. This language is often advertised as a systems language, and I'm not sure whether this is helpful, because I saw that flying around so I saw Rust flying around on Twitter a couple of years ago, and I always thought this is not for me because I don't write systems libraries. But I think it can do much more. It can do really high-level abstractions, and they come at 0 cost. So it doesn't make the code slower to write abstract, to use abstractions. I don't have to write a low-level code. Also, once you start using it, you will see that the compiler catches most errors, which is annoying at the beginning, because at the beginning you spend most of the time wrestling with the compiler. But once the code is compiled, you actually can be confident that this is correct and it's just working. And it can be weird. I mean, this effect like here, fry on the image suddenly. So this is compiling and then it just works. And it can be really a surprising thing, because in other languages, it's not always like that. Compiler provides helpful error messages. Maybe I'll show that. All the variables and all the functions are private and immutable by default. So I have to, if I want to modify things, I have to make them explicitly immutable. If I want functions to be publicly visible, I have to make them explicitly public. And I think this is a great default. And maybe the best thing is the tooling. So it comes with batteries included. And so testing is already there. You don't need an extra library. Documentation framework is there. Auto formatter. So there is no discussion about should we use 2 indented 2 spaces or 4 spaces, or should the brace be on the same line or the next line? There is no discussion about it. So a bit similar like in the Go language. There is an auto formatter, fantastic dependency management, package registry. You can publish your package. Again, I think this is just simple, easier than in Python. Also, you don't need any make files. You don't need CMake, you don't need make. You just put the code in the different files, and it will, and you can compile it. Which I find nice, because then I can focus on the programming, and I don't have to focus on all the extra plumbing in all these different libraries. So a little breather, I will get a sip of coffee. So again, please ask questions in writing or in voice at any moment. Super. Some frequently asked questions. Okay, is it as fast as Fortran C or C++? Yes, it is. How about my favorite scientific library? Is it also available in Rust? Often yes, and if it's not, Rust language has very good interoperability with C and with Python, as I will show. So you can use your favorite library if it has a C interface, and most of them do. And do we need to rewrite all the code? Like if you have Fortran code, do you need to write it? Of course not. You can also talk to Fortran via the I2C binding. Shared memory parallelization is easy and it's thread safe, and I will show it. How about message passing interface? I think it's still a bit too early for this. So if you want to do MPI, maybe a good combination can be to do the MPI on Python side and then the shared memory parallelization on Rust side. And I see the question about CUDA HIP. I have no own experience with this, but I think there are libraries. I would in doubt go through a C interface, but I don't know. If somebody has more experience, would be fun to hear. And I mentioned all these great things about Rust. One thing that is difficult for newcomers when you arrive to the Rust language is that the memory model is really different. It's different than C++ Fortran. It's also different than in Python. There is no explicit allocation and deallocation. So you don't need to allocate an array and you don't need to remember to deallocate it. And there is also no garbage collection either. It's not like in Go or Python, where you also don't have to allocate and deallocate, but there is a garbage collector running through the functions. This is not there either. In Rust, it's different. Each value has an owner, and there can only be one owner at a time. And when the owner goes out of scope, the value is dropped. So there is an ownership, and it works a bit like, I think one way to imagine it is that Rust memory is managed a bit like money. There is one owner to the money. I can borrow the money, I can show it to somebody, I can transfer it to somebody, but two people cannot spend it at the same time. And this can lead to, so when you start with Rust, you can be a bit surprised that code like this is actually not compiling. What we see here is that I create a string, I call it S1, and the string contains hello. And now I assign the value of S1 to S2. At least that's what I think is happening. And then when I try to print S1, it will complain to me that because now I have transferred the ownership so the ownership has moved from S1 to S2, and this will not work anymore. Of course, there are then different ways to do that, but this can be a bit surprising once you start, when you arrive from Python or one of the compiled languages. But this ownership and borrowing rules, they have huge advantages because they make then we don't have to worry about thread safety because there is always only one owner. So we cannot get into the situation where one variable is reading and the other one is writing, and we don't know which one goes first. Just scrolling here on HackMD. Yeah, okay, so what happened to S1 in that example? S1 lost ownership of that value. It is dropped. We can imagine that it's deallocated, but the allocation actually moved from S1 to S2. So we can think of it as S1 deallocated, S2 got allocated. And here's some links to more reading. Especially the Rust function interface omnibus is fun because it shows how to combine Rust with different languages. Let's have a look. For instance, so there are some examples here. Basics. So how to interface with C, Ruby, Python, Haskell, Node, also Julia. I was here. There was this Nature article, why scientists are turning to Rust. And some books, some of them are open. I actually, when I started with Rust, I started with this Rust by example and the Rust programming language book. Okay, so that was a brief intro into Rust. Now, why Rust and Python? Because, so we have this two-language problem, but we can turn it to our advantage. We can use the best of both worlds. Python has a huge ecosystem. I mean, so does R and so does Julia. It's just that, I mean, this talk is about Python. So Python has a huge ecosystem and a huge following. And I think it's nice to be able to connect to it. Many people are familiar with pip installing software. And this is a mechanism that I will show to distribute code. So I will write in Rust and I will write a little Python layer around it, and it will be pip installable. And anybody can import it into the Python code. And they don't even have to know that this is written in Rust. So connecting to this huge community. But the other situation where I use that is to speed up a bottleneck in a Python code. I really like Python because I like that I can prototype really fast. So if I have an idea, I can implement it quickly in Python or more quickly than in other languages, so I can test it. But I sometimes come into the situation that there is a portion of the code which is too slow. It doesn't happen often, but if it happens, then I can maybe move that bottleneck to Rust. What I do in my work, in this oceanography work, is that I sometimes want to test an idea before implementing it in Rust. I want to test it, whether this is working at all. And I'm maybe not interested in the speed. And then I often test it in Python. And then it can be nice that I can then successively move portions of the code over to Rust. And then I like to do that to like bulletproof the code, the prototype, because then porting to Rust makes it more type safe, more robust. I have more confidence into the code and also faster. So these are different situations. Also, well, often we don't start from scratch. So even if it doesn't matter what my favorite programming language is, often we enter a project and there is already code there. And then it's nice if I can combine it instead of writing from scratch. So to connect existing codes. And this is also why I'm so interested in combining languages, not only Python and Rust, but I think there is really a need for more training on how to combine building blocks written in different languages, because that's a situation that we often find. Okay, a few more slides and then I will switch to the terminal and we will try a few things out. And so now about how to do it. There are many ways. The way that I really like and that I will show is using this Pythonium trioxide library, the oxidized rusted Python. This provides Rust bindings for the Python interpreter. So you can call Rust out of Python, you can call Python out of Rust. I will show you this page here. It has a very helpful community for questions. So I have asked some questions there and I got really quick answers. The one page I wanted to show you is the type conversions. So what this will do here, and let me know if the font is too small. This library will help me creating bindings between Python types and Rust types. So I don't have to use only basic data types like int, float, string. I can use lists and they will translate to vectors in Rust. And in Python, I can use dictionaries, and they will translate to hash maps and sets to hash sets. So I can write, it doesn't have to be simple code. It can be normal code. And then the second tool I will show is from the same, it comes from the same ecosystem, Maturin, also from the PyO3 group of developers and projects. And it's a tool with which I can build a Python package into my virtual environment. So I use that when I develop. It can check whether the package conforms to many Linux. This is important if I want to distribute a package on the Python package index, because then I can be sure that this will run on any Linux machine. But this will limit me in terms of dependencies. So this tool also checks that I'm not using any dependencies that other people don't have. And it helps me to publish it on PyPI. And I will hopefully have the time to show you also how I do that on using GitHub Actions. So what I will show is that we will create a release on GitHub, and then it will run the workflow, and it will upload the package to PyPI. People can install it with pip-install, and they don't even have to know that I wrote the code in Rust. Good question about publishing source packages to PyPI. Yeah, so this you can still do, but then it would have to be compiled on the client side. So I think it can be done. What I often prefer is that I distribute binary packages, which I built on my side, so that the person using it doesn't have to install Rust. I haven't tried distributing source packages, but I'm sure it can be done. But it would require then, I guess it would require that Rust is installed on for the person who does pip install. I want to mention that there are alternatives. This is not the only way. One alternative is the C foreign function interface in Python, which is also one of the favorite things that I like to use. Swiss Army knife it will create C interface for my Python code, and then Rust can talk to it like to a C language, and Rust is very good at that. So that's an alternative. The PyO3 is probably simpler. Yet another alternative is using C types, and there are some examples here. But I will show this PyO3 Maturin combination. And let me see what I have left. So these two examples, I will first jump into the nearest distance for a set of points. I will call into my machine, and we will explore a bit. I will show you a few things that I just mentioned here in passing. Then the other example, and then hopefully I will show you how we deploy that to PyPI. And if not, then all the links are here. So now let me rearrange my windows a little bit. Also a good moment to ask questions. Okay. So now I will share something else, and that's the whole desktop. And I can imagine that the font is maybe not ideal. Please let me know whether this is here visible enough, readable enough. I would like to show two terminal windows because I would like to compare Python and Rust and discuss a few things. But please let me know if this is not really readable on your side. Okay, I will go to this first example. And the examples are linked, so if you want to clone them or check them out later. It's this distances example. And I will open the Python code first, tell you what this is doing. And then I will compare that with Rust. And then we will try to make them talk to each other. So in this Python code, what I do is I generate, is this readable here? Can somebody let me know?
Seems readable to me at least.
So in the Python code, what I do is I generate random points with x, y coordinates. So they are somewhere in space. And I want to generate many of them, 5,000 or 1,000,000. Why does it look so weird? Okay. So we generate lots of points randomly in space. And then what I want to know is I want to know for each of these random points, I want to know what is the nearest distance to its next point, to what is the distance to its nearest neighbor. And this is how I compute it. And this is not an efficient algorithm, but I just wanted to keep things simple. So this is an algorithm that will scale n to the squared, because for each point, so for each reference point, I go over all the other points and I find the smallest distance. And the distance, I compute it like this. So it's the difference of the x components squared plus the difference of the y components squared, and then the square root. It's not super important how everything here works. I wanted something that takes a bit of time if I have lots of points. Okay. And I would like to do that in, so then I can run this. Actually, maybe it will be helpful if I can, let's just test it out. Let's test the code out, maybe for, let's start with 10 points, just to see what it's doing. So let's print them, print points. And then it computes these distances, and let's print them to print distances, just to get a feel of what's going on. So how I produce 10 points, 10 random points in space. They are here. Each of these points has an x and y coordinate. Something didn't work here, and this is because there was a mistake. And then I compute these 10 distances. And we could imagine that this would be used in, I don't know, to compute the social distancing for a large number of people moving around in space. All right. This is actually quite close to what I'm normally working on, but I'm working on a bit more complicated algorithms than this one. But now let's inspect the same code in Rust, because then we will learn about what is similar, what is different. So I'll go in here, and there is a lib.rs where I have a similar code. So on the left side is Python, on the right side is Rust. And we see that, okay, there is something similar. One thing that is different is that everything has a type. So I'm telling Rust that this point 1, it will be a tuple of 2 floating points. Same point 2, and at the end, what I want to get out is again a float or double. So then the Rust already knows. And the Julia developers here, they also know this concept, because you often want to restrict the types. So on the right side, we have statically typed code. On the left side, we have dynamically typed. Here, the types will be figured out at runtime. Here, the types are already known at compile time. And really similar, so the nearest distance one would be here. Similar things are happening. There is again some type annotations. The other thing that is remarkable here is that this mute. So here I have defined a variable to be mutable. If I had left out mute, I would not be able to modify this variable. I have also mentioned that all the functions are private by default. So these functions here, I cannot call them from outside. This one I can call because this one is public. So this would be like the underscore convention in Python. So just wanted to reconnect a bit to things I've mentioned. I could talk more here about type and type inference, but I think I want to now focus a bit more on the Python Rust part, but we can come back to that if there are any questions about types. And let's maybe run also the Rust code. Should we run the Rust code? Yeah, we should. Just that we see how to build it. So in Rust, the tool that has everything, that is testing and documentation and packaging and auto formatting, everything included, is called Cargo. And with Cargo, I can do different things. I can build my code. Great. Okay, already there's a problem because I'm probably in a different version environment. So I think there is a leftover from before the call, so ignore that. I don't know if my microphone picks up that my computer is now running the fan, because now it's fetching the dependencies, compiling all the dependencies. You can see that somewhere I have already defined that I want my package to depend on PyO3. And I have defined that in the cargo toml. And for those who have been here for the last seminar with Julia, this is similar to the configuration and dependency management that Luca was talking about in Julia. So my package will depend on, I want random numbers, and I want something else, and I also want to have this PyO3 library. And with cargo build, I can compile. Cargo run, I can run my binary. So now it computed some distances. I can type check. I can auto format. I could run cargo test, but now I didn't define any tests. Good. But what I want to do now is I want to call this nearest. Sorry, I want this one. I would like to call this function out of Python. And then I want to compare the runtime between the Python implementation and the Rust implementation. And it turns out that there is not very much that I need to do. If I have an existing Rust code to expose this to Python, I need to uncomment 2 lines here to make this PyO3 library visible, so that I can use. Now what I will do is, all I need to add here is something called PyFunction. Voila. And now this function will be visible on the outside. This, you can think of this as a Python decorator. So I decorate this function, and then this PyO3 will know what to do, and it will create the bindings for me. I will actually do one more thing. I will uncomment this thing here below, because not only do I want to make the function visible, I also want to make a module visible, so that I can import the module, and I can give it a name, and here I call it distances, but I could call it something else. And in the module, I want to define a version, and I want to make this function here visible, nearest distances. So what I like about this PyO3, so that's it. That's actually all, as we will see, that the Python interface is very thin. I don't have to write a lot of code to make this shim between Python and Rust. All I did was ask for the PyO3 dependency at these 2 lines, and then all the functions that I want to be visible in Python, I mark them like this. Later, I will also show you how you can mark classes, and then I create this Py module. And of course, it can do a lot more, and a lot more you find in the PyO3 documentation. But now that I go out, let's go out here. If I now do cargo build, see whether this worked. Seems to work, but I didn't save. Now I saved. So now it compiled it. It built the Python interface. And now I want to show you this. So back to my slide deck. Now is the moment to start using this Maturin tool, because I will now build this. I want to install this into my virtual environment for testing. So what I do here is in my requirements.txt, I require Maturin, and I will install it into my virtual environment. And I use this, in my case, is an alias VE. The VE, it's an alias for me to create a virtual environment and install everything that is in our requirements.txt into it. So long story short, I have now Maturin. What can Maturin do? Maturin help. I can build this package into my virtual environment. I can develop. I can also publish. So we'll do that later. I can publish to PyPI. So let me try Maturin develop. Super. So now something happened. What happened is that it installed it into my virtual environment. Now I can access this in Python. So let me try that in the Python shell. Now I should be able to import distances, the module distances, and I can. Let's try this thing here, help distances. So it doesn't tell me too much. It tells me that there is a version, there is a function, nearest distances. I'm not so sure how I can call it yet. So one thing that can be really nice to do is here to add a docstring. And these are docstrings in Rust. So in Rust, comments have two. This is a comment, but if I have three, then it's a docstring. So I have a docstring, and now if I go out of this Python thing and I rebuild, let's try that again. Import distances, and now let me try again. Help. That didn't work. So what I was expecting to see is that there should have been a docstring here. Interesting. Interesting. Is it because should have been? No, I don't think so. So something is not. All right, let's return to that later. So the point of this demo was to show that we can have docstrings here. They are not only meaningful for us, but they are also meaningful for Python, except that it didn't work now. I think I don't want to spend too much time on this little detail. For me to investigate, I would now like to go and actually try out the functionality and the timing. So let's do it. Let's go into example. Apparently, what I can do now is I can import my Rust code. And here I can compare. I can compare it to my Rust implementation. And I will call them distances that come from Rust. And what was the function called? It was called distances, nearest distances, I think. Let's compare. I forgot already. Yeah, so there is a module called distances, and it's this one. And there should be a function available called nearest distances, and it's this one. And I should be able to send a Python list into it of tuples, which the interface will then translate into a vector of tuples. Then Rust will do its magic, and it should be able to send back distances. Hopefully the DS Python and DS Rust should be the same. Let's verify that. Let's just compare the two. Would I get the same result at all? So first thing I want to see, is it working? Then we want to see, is it fast? Python example. So it looks like actually working. So we get the same numbers from both languages. So this one calls the Python one, this one calls the Rust one. And just to show that I'm not really cheating, it does this hello from Rust. Where does that come from? The one came from here. So it tells me hello from Rust, and then it returns these points. Oh, the distances. Good. Let's time it. And I see that we have 10 more minutes left, but it's good. We will make it. Let me time the Python one, T0. And then here I will say print time spent in Python is this minus T0. So this time perf counter is useful for timing. I mean, I use it for very simple timing of functions. This is not very sophisticated, but it will give me an idea. And the same thing I will do on the Rust side. Time spent in Rust. I don't need to do this. I'm confident in the values match. Now I want to check it for a bit more points than just 10. Let's do 5,000. So what I expect to do is this thing will compute 5,000 square distances. So let me build this thing. And now let's try. This takes already a couple of seconds. Should take like 10 seconds. This gives me time to catch up with the HackMD. What does this mean, the ampersand? I can pass, it means that I borrow only the reference. So where is that? Here this ampersand means a reference to the vector points. So I showed you this at the beginning. We were copying this string hello, and here I don't move anything. I send the reference to it. So passing by reference, the nearest distance will not modify this. It will be read only. What does cargo check? It actually checks that all the types match up. So it will not build and link the code. It will only check that the types checked up. So it's faster than cargo build. I often use cargo check. In fact, once you start using Rust, you will see that you often don't even run the code. You just compile it, and then you continue developing, and then you compile again, and then you continue developing, and then at some point you actually test it. But then you stop even compiling. You just do cargo checking, because already checking that the types are matching is already enough for me often. So I type check, and I continue coding, and I type check. And at some point I build, and at some point I test. All right, coming back to the timing. So we ran this timing, and it's not impressive. So it got a bit faster, 10 times faster, but it's a bit maybe disappointing. But there are several reasons to this. One reason is that I actually didn't compile with, I compiled with debug flags, not with optimization. So let me, in Rust, I can build in Rust I can build with, this is the debug. This is a debug build, but I can also build with optimization, which looks like this release, -- release. And I will now also in Maturin, I want to build this Python package with optimized code. So this will really help a lot. And this is the one that we then really ship. It takes a while now the first time because it needed to also build the dependencies. And if I now run the test again, 5,000 points. Thanks for this question. I will try to come back to it. So this already helped a lot here. We are now something like 200 times faster. We can still improve things. And for this, I will go to the library. There is this wonderful library called Rayon, which I will uncomment. And it's something that allows me to parallelize loops very, very compactly. And I can be absolutely confident that I will not introduce any thread problems and race conditions. And all I will do here is this iterator, which iterates over all my points. I tell it to use a parallel one. And just by this one change, so I changed 2 lines in my code. Just by this, I will now use all the available cores on my machine, which happens to be here. Let's have a look. So here there are 12 of them. And now if I run it again, oops, let's run the timing again. We will maybe see that all the cores will be for a short while, they will be really busy. Let's check. I think we are still running the Python part. I think that the Rust part was simply too short to see anything. And now things got again an order of magnitude faster. So I like to use this. So we gained a lot by going to a compiled language, the one with restricted types. I also like to use it to do shared parallelization, shared memory parallelization on the Rust side. So I think this is what I wanted to demonstrate in the first example. The second example, I can see that we don't have too much time left. But I want to show the essence of it. So if you go to the GitHub repository, in this example, I define an object, a class, sorry. I define a class account. And I want to create a Rust code that creates a Python package called accounts. And then I can create bank accounts. So there is account 1 and 2, and each of them I deposit 100 kroner into it. And then you can deposit money to it, and you can withdraw money from it. And then you can print the balance. So this is relatively simple code. I want to show you now 2 things for the sake of time. I want to show you how that looks on Rust. The way it is built is exactly the same as in example 1. But then I also want to show you how do I get it to PyPI so that we can pip install it. And then I will install this example and run it on my machine. So I wanted to show you how does it look in Rust. And this is how it looks. So this is a struct, which in Python, the equivalent thing of this is a class. So I define a class called account, and it holds some data in it, in this case, the balance of the account. And then I have a couple of methods. So I can create the class, I can deposit money to it, withdraw money, I can get the balance. This we already recognize from the first example. So I need to somewhere define the Python module. I have showed you in the last example how to define Py functions. Here I define Py methods and a Py class. And this will make this visible on the Python side. But I want to go one step further. and use Maturin to also publish this package. And I like to do that by putting this into a GitHub workflow. So this is a GitHub action which I want to run every time I create a release. And then on Linux and on Mac and on Windows, it will basically do a Maturin publish. So instead of Maturin develop, it will do a Maturin publish. And I use a token to authenticate so that I can deposit this on PyPI. And here, just because I didn't want to junk up the Python package index with my simple example, I put it on the test PyPI. But if I would leave this out, it would go on the PyPI. And the code is, I did that already yesterday, or just need to find a tab. Okay, Zoom is in my way. This is bad. Okay, here's the tab. So the code is on PyPI, and you can try it out. I will try it as well. So I can. I will step out here. I will create a new test folder, and in here I create a new virtual environment. This is my shortcut, and I will install pip-install this Rust code into it. Pip-install accounts, and it fetched menu Linux. Do you remember what that was? That was this thing that now runs on any Linux machine, hopefully. And now I can do this. Example py. What do we expect? We expect account 100 kroner, and then I add 50. So one should have 150. The second account should have 75. Does that work? Yes. And what is really beautiful here is that nobody knows that this is Rust code. I can connect to the Python ecosystem. Like it looks like any other Python package. And even we can use here a struct, a class which was defined in Rust. And I think this is really a beautiful approach. PyO3 can do a lot more. Maturin can do a lot more. I can see that I've already used 1 hour. I didn't want to use much more. Let me come back to the question that I skipped over. So PyO3 seems to have ways to reflect Python types into Rust. To have reflected wrapped Rust types in Python, like PyPI boost Python. I'm not sure I understand this. Rust types in Python. Maybe that was maybe the question was what I showed here. Maybe maybe I don't understand the question, but okay, good. All right, yes. So we have defined a Rust type, and we can give it methods, and then we can make it visible in Python. Yes, good. So that it somehow made sense. Was there anything else in my? So in the HackMD and in the slides, you find pointers to these repositories. There was a lot that I didn't discuss. I would love to talk more about it.
Yes. So if there are no further questions, yes, Radovan said the videos will appear in YouTube, and thank you everyone for listening and participating, and especially thank you to Radovan again for the very interesting talk. And I will now stop the recording.